Hello and welcome to today's Fireside Chat, Relational Database Innovations at AWS. Before we get started, I have a few quick housekeeping items. On the left side of your screen, you will see a Q&A pod. Please submit your question for our presenters and moderators at any time, and we will address them when they come in. At the conclusion of today's presentation, there will be several poll questions during Q&A. Please provide us with your feedback when you see these questions appear on your screen. Today's webinar is being recorded. In the next few days, we will send you a follow-up email with the on-demand links to the presentation deck and webinar recording. Again, and welcome to today's Fireside Chat, Relational Database Innovations at AWS. My name is Larry Weber with AWS, and I will be your host for today's webinar. Joining me is Debanjan Saha, General Manager of RDS. Today we're going to be discussing RDS, what makes it special, and how our customers are using it. So thanks for joining today, Debanjan.
Thank you, Larry. Thank you for inviting me.
Awesome. Great for you to be here. And I want to start with everyone. Maybe we can talk a little bit about your background, maybe how you got into AWS and a little bit about your history.
Sure. So I'm actually a network engineer by training. I finished my PhD in networking back in the days. I'm not going to tell you the date and expose my real age. After that, I went to IBM Research and was there for about 3.5 years. Mm-hmm. Then I went to a startup. This was a pretty hot startup in the optical networking area.
Oh, wow.
And we did an IPO in 2001. And after that, what happened to the market. Mm-hmm. After market crashed in 2003, we sold off the startup. I came back to IBM, and I started working on storage. And I led a team to implement a virtualizing storage controller, which became a pretty big business for IBM. After that, I went to Shanghai on an international assignment. I was there for 2 years with my family. It was a great experience for everyone. I came back to US in 2014, and I was thinking about doing another startup, move to Bay Area. And then I got a call from AWS that, hey, do you want to do something exciting in the storage area? Because they knew me as a storage guy. Yeah. And I told that executive who was calling me that, look, I just moved from New York to Shanghai to California. I don't want to move again. Do you have anything in California? They said, well, we do have something in databases. You may be interested in that. Nice. So I went and talked to my current boss, Anurag, and he said, look, I cannot really tell you much about what we are doing, but I can guarantee you this will be really exciting. I said, okay, all right. So I walked in there, and that was Aurora. And, this was actually much more exciting than what I imagined it to be. As you probably know, that Aurora is the fastest growing service in the history of AWS. It's one of the best cloud-enabled relational database services. I also, of course, run all of RDS now. Sure. But that's the brief history of what I've been doing.
No, that's great. And so let's talk about RDS, or RDS, a relational database service. How would you describe RDS to someone who's new to the cloud or even new to AWS?
So I think the easiest way of describing this, no matter who you talk to, they have a database, most likely a relational database. And if you want to run relational databases in the cloud, and if you want AWS to take care of management of the relational databases, RDS is probably the best place for you to go to, right? We offer a lot of choices. So whether you are using open source databases like MySQL or PostgreSQL, or you are using commercial databases like Oracle or SQL Server, or you want to use a cloud native database like Aurora, we have an option for you, right? And it is, as I mentioned, Aurora is the fastest growing service in AWS. All the databases that we run, we probably have hundreds of thousands of databases that we manage, right? And this is one of the most popular database service platform that we have, of course, in AWS, but any other cloud platform that you can probably imagine.
Gotcha. Yeah, one of the things I'd love to hear from you on, and a lot of people asking, when you talk managed service, right? What does that really mean? What are we managing? It's not just, hey, database in the cloud. We're doing some other stuff too as well.
That's right. So, the easiest way of explaining this is that when you run a database, it is actually a complex task. You have to provision a database. You have to sometimes scale the database. You have to, for example, patch your database. You have to take backups. Sometimes you have to restore. Sometime, you have to comply with various different security standards that you have. We take care of all of that for our customers, right? So that is the biggest value that we bring in terms of managed services. Also, there are a lot of other things we do. For example, if you think about Aurora, and if you want to build, for example, a cloud-native application, we offer serverless implementation of Aurora, right? This is something which probably you wouldn't find anywhere else. So it's not just the management of it, it's also helping customer build their application on relational databases that we help customers with.
On that topic, serverless, can you describe what serverless is, and then how do we implement that?
That's right. So it's a new concept, right? So, oftentimes people come to us and say that, yes, I want to run a database, but I have a variable workload, right? I mean, for example, if you're running a test fleet, you probably are not using it during the weekend or the weeknights. Sometimes people have applications which are intermittent. For example, I was talking to a customer, he runs a custom blog feed or custom news feed. And his application wakes up 3 times a day, runs for 10 minutes, scans the web, finds out what the new news feeds are, put them in Aurora, and goes back to sleep. He doesn't want to run a database for 24 hours a day,
right.
7 days a week. You're talking to another large customer, actually an enterprise customer, and they run their database 24/7, but it actually goes up and down in terms of workload, and they don't know how to right size that database. These are the kind of databases where you don't really want to provision a server or an instance for the database. You want that to auto scale, and sometimes auto scaling means you probably want to scale down to 0, where you don't have workload, you don't have a database. So that is the concept of a serverless database, right? You are not provisioning a database server. You are actually provisioning just an endpoint, and you send your queries to them when you have it. And we spin up the database right in time to serve you, and we spin up exactly the right size instance that you need.
As more demand's needed, it kind of grows and shrinks as demand is
exactly.
there. Wow, that's pretty cool. How about so that's Aurora, the serverless feature. How about the rest of RDS and scalability? How does that work?
That's right. So, as I said, RDS actually offers scales in various different dimensions. So, for example, you can create a database of various different sizes, from very tiny database, we call it the micros, to all the way to the large XXL databases, right? For example, the 16XL databases, right, which are really, really big servers. And people have simple APIs that they call in order to scale their database. Similarly, on the storage side, we provide scaling of the storage as the database grows, right? People, for example, create a simple one instance database, or they can create a cluster with high availability, right? So you offer different types of scaling there. Scaling also comes in a different dimension. For example, we are managing hundreds of thousands of databases. So in order to do that, we have to scale our management plane or our control plane, right? I mean, this is something we have learned over many years, and we probably do that better than anybody else. And as a result of managing these hundreds of thousands of databases, we actually know what are the different problems different people are facing. And some of these we figure out before somebody actually faces the problem, because we have seen it somewhere else. And that experience is very, very useful in running a managed service.
No, that's great. And how about something like high availability? And how does that compute into maybe introduce the AZs, availability zones? And how does RDS and how does the managed service interact with that?
That's right. So let me give you a couple of examples, right? So AZ, as you said, is really a data center, and we have multiple AZs within a single metro region, or single region we call it. So you have essentially multiple data centers within a region. And these data centers are completely isolated, and they don't share any common risk, right? Except, of course, for the whole city going down in some sense. Now, what we do in our multi-AZ is that you can create a high availability cluster where you have multiple instances in different data centers. And we automatically monitor all of these instances, both the primary and the secondary instances. And if something happens to the primary, we automatically fail it over to the secondary without any data loss. And the key point here is without any data loss and very, very quickly. And I'll give you an example. Let me give you an example from Aurora. Aurora supports a very, very highly available multi-AZ architecture. And typically AZs don't go down, but sometimes it happens. It happens once when there was a typhoon in Australia. One of the AZs lost power and it was down. And all Aurora databases, except for the ones which had instances in the affected zone, were up and running without any hiccup. And the ones which are affected because it was in the affected availability zone, that came back up within a minute.
Oh, wow. That's great. So how about, let's turn a little bit here and like get into the actual database engines that we have within RDS. What databases do we support?
Right. So, we are an everything store. We believe in providing choice to our customers. So we offer open source databases like MySQL, MariaDB, and PostgreSQL. We also offer commercial databases, Oracle and SQL Server specifically. And then we have our own database, Aurora, which gives us the availability and performance of commercial databases with the simplicity and cost effectiveness of open source databases, which is something that we build from scratch. It is optimized for the cloud, and it is optimized for applications that's born in the cloud, as well as commercial applications.
Oh, that's great. Hey, so how about like, I'm knocking on the door of AWS. I'm like, how do I get started with this today? I mean, how would you recommend customers go find out about RDS or get started?
So, well, I mean, you can come to our website and read about RDS. We have a lot of information on the website. There are a lot of blogs that you can read. And once you are ready to use it, you can actually log into an RDS console from AWS console. And within a couple of clicks, we can have your database up and running. It literally takes a couple of clicks, probably a couple of minutes for a database to be fully provisioned for you.
Oh, wow. So how about the difficult story? How about I'm an existing customer with an existing on-premises database?
That's right.
I hear, wow, this sounds like great. I would love to do this. How about migrating to the cloud or migrating my data? How would a customer go about doing that?
So we actually offer many ways of migrating to cloud, right? So for example, we offer a service called Database Migration Service, and that, with a few easy steps, you can set up migration from either commercial databases to commercial databases or commercial databases to open source databases. So it could be both homogeneous migration as well as heterogeneous migration, right? So if you are planning, let's say you are running Oracle and you want to move to Oracle, we support that. If you're running Oracle and you want to move to Aurora, you can do that also, right? So we have seen many people who are essentially doing lift and shift. They, in the first step in their journey to cloud, they don't want to change the database that they're running. Yeah. And we support that using DMS, and there are other ways of doing that, of course, but DMS is an easy way of doing that. And there are people who would like to re-platform. They are running on commercial databases, but they would like to move to an open source database. It could be, for example, MySQL or Postgres, or sometimes they choose, either Aurora MySQL or Aurora Postgres. And it's pretty simple to get them migrated. We also offer professional services so that if they need help with respect to migrating not only your databases but their whole stack, we offer that facility also. That's
great. So how about those people, maybe they're already in AWS and they're leveraging something like EC2 and they're leveraging their entire data store within there. Is RDS offer value to those people as well?
Absolutely. I mean, there are a lot of people who, of course, run their databases on EC2, right? I mean, but many of them would really like to focus on running their business, building their applications, and they don't want to get into the details of managing a database per se. And those are the customers who choose RDS because we make it really, really simple for running their databases, right? I mean, most of the things that people have to do just to keep a database up and running, just to, for example, apply patches when there is a security hole somebody has exploited and they need to patch their database immediately, or they have to comply to some industry standards like PCI or HIPAA or something like that, or somebody really needs to set up a high availability environment and trying to figure out how to replicate. or even simple things like backup or point-in-time recovery. They don't want to really deal with that, right? We do all of these things for our customers, and this is tremendous amount of value. I mean, I have seen, for example, typical industry standard is that you need probably a DBA for every 20 or 25 databases you have. I have customers who are running a fleet of 500 databases with a single DBA.
Wow, that's amazing. Let's think through RDS. We have all these different engines. You mentioned, the commercial engines, the open source engines, and then also Aurora. I want to spend a little bit of time because I really want to articulate what makes Aurora so special.
Right.
And what would you tell to a customer? Hey, why should I adopt Aurora? Why is that different?
Right. So there are different ways of kind of explaining that. Let me start with the business value, right? I mean, the reason we developed Aurora because we had customers who were open source using open source databases, and they wanted something which is more scalable, more available, more performing. And we had commercial customers who were happy with the scale and availability that they get for their commercial engines, enterprise class scale and availability. But they didn't want to manage licenses. They didn't want to pay for those licenses, which, as you know, can be very, very expensive, right? So we wanted to build something which essentially combines the best of both worlds. That you want to have the simplicity and the cost effectiveness of open source databases, right? And you want to have the performance and availability of enterprise and scalability of enterprise databases. That's what Aurora is, right? It is fully MySQL compatible and Postgres compatible. There are actually two flavors of that. And it gives you the enterprise class availability and performance at the open source prices, right? So that's the business value of it. If I step back a little bit, architecturally and technologically, how this is different, right? I mean, as you probably know, System R, the first relational databases, was developed in 1970s in IBM lab in Almaden. I actually know some of these people.
Wow.
And it was a good database at that time. It was based on it was a database that was developed for mainframes, and not much has changed since then in the world of relational databases. If you look at today's commercial databases, they pretty much have the same software stack. They probably create, clusters where you have replicas of the same stack connected in various different ways. The fundamental architecture haven't changed. And those databases were designed to optimize the consumption of hardware resources because they were really expensive those days. Memory was very expensive. CPU cores were not that many in a particular architectures that were designed for. Storage was very expensive. That's not the case anymore, right? So we actually have designed Aurora for the new age, the cloud age, where there are abundance of hardware resources, and it is optimized to take advantage of that. It is also designed as a service-oriented architecture. We don't build everything from scratch. We actually take advantage of services like S3, right? Services like IAM, services like Lambda, and integrate with them. It helps us not only build the database features very, very quickly, it also helps our customers to build their cloud-native application on top of Aurora much quicker than what they can do on traditional relational databases. And the third thing I would mention, which is essentially an attribute of RDS, which is the management platform on which Aurora and other databases run in RDS, is that we have made the management of the databases as simple as possible, right? All these things that people have to do manually in their environment, they don't have to do that anymore. These are the three fundamental ways Aurora is different.
So it's taking care of a lot of the difficult work as well, even behind the scenes, to be able to get that type of performance.
That's right.
Awesome. So one thing I do know is a lot of the innovation that's been coming out of the team has been through Aurora, and there's been a number of different releases and features that have been added to it. And I'd love for you to kind of explain maybe a couple of them. One would be Backtrack. Would be one. What is Backtrack, and why does it matter?
That's right. So this is a new feature that we have added, and people do make mistakes, right? I mean, I have done that, managing databases, that you accidentally drop a table. Right? You do something and they say, oh my God, how do I undo this? So Backtrack is really undo for databases. If you accidentally do something And if you go back in the past, as if you're on a time machine, and say that I want to go back to the time before I made that mistake, you can do that with Backtrack.
That's great. No, that's great. Like Backtrack and serverless, and I'm
That's
just
right.
hearing a lot of more stuff that's coming out as well. One question I really have for you, and I think people will be really interested in, is how people are leveraging Aurora and some of these features in unique different ways. Do you have any use cases outside? We talked before about serverless, and
Right.
a dev test is one, and maybe new applications.
Right.
Like it grows as needed. How about some other ones? Maybe more enterprise class for Aurora. How are people tapping into this?
That's right. So I'll give you examples from some of the newer features that we have just released or are in preview that people are using. One of the new things that we are doing, we call it parallel query, right? So, I was talking about taking advantage of hardware, abundance of hardware in cloud. So if you look at the Aurora storage layer, it is distributed across hundreds, sometimes thousands of machines, right? So this is massively parallel multi-tenant environment.
Yeah.
And each of these storage nodes is really a powerful server with SSDs in them, but very powerful CPUs. So what we have done in parallel query is to push down the execution of the query from the database engine to the storage layer, where you can parallelize that 100 ways, sometimes more than 100 ways, right? So suppose you are running, a lot of people store operational data in Aurora, and they would like to run, for example, a report every day in the morning, which touches all the rows in a database, which spans, tens of terabytes, right? If you run it in a regular OLTP database, it's probably going to take a long time. With Aurora Parallel Query, we have seen in some benchmarks, we are getting 100x, 200x improvement in performance,
Wow.
right? I'll give another example, cloning, right? So this is a new feature that we released a few months back. And the idea behind cloning is that you can very quickly create a copy of your database without fully copying the entire data set, right? So what we do is really a virtual copy where you keep pointer to the data pages, and it takes a couple of minutes to create a clone. Now, why clones are useful? Sometimes people would like to run, for example, test or performance benchmark on production data, right? And with clones, they can, within a couple of minutes, can create a copy of the database, run their test, and then delete that clone, right? Sometimes people use the clone to reorganize their database in a big way. Let's say they are planning to add new tables or reorganize their schemas and the tables.
Yeah.
Instead of doing that on production database, they make a copy of the production database on a clone and then use that, right? Another interesting feature in Aurora is our read replicas. Read replicas really are reader nodes, which people use for read-only queries.
Okay.
Right? Let's say you are, for example, an e-commerce site. You are changing your prices every hour or every minute, and you have many customers who are coming to your catalog and reading that. So in Aurora, you can have a master and up to 15 read replicas, which are essentially consistent or essentially knows everything that the writer is doing almost immediately, right? So that helps you scale the read queries that you see from, for example, a website which is running catalogs, and we have many customers who are doing that. Another interesting place where I have seen Aurora being used extensively is is gaming.
Oh, yeah.
By the way, this is one thing that makes me a cool dad at home, because I have a 13-year-old son and he doesn't know what else I'm doing, but he knows that dad is working on something which is running his games.
Nice. Yeah, my kids would love that too. No, that's awesome. So, wow, if you think about it, Aurora's only been around for a short period of time.
That's right.
And it was Aurora MySQL. Now we have Aurora Postgres.
Right.
And now we have a number of new features that are building into this. A little bit forward thinking here. What do you see for the future of Aurora? What do you see the next big thing that you can share with folks?
Well, there are multiple things that we are working on, right? I mean, the way I think about it, what are the different types of workload that I would like to attract into Aurora, right?
Okay.
I mean, yes, we have done serverless, but there are a lot of interesting things we are doing on top of what we have done for serverless already. For example, we are going to have HTTP endpoint for serverless. Typically, people connect to databases using JDBC connection, but in a more service-oriented infrastructure where you have Lambda type of application or serverless applications, they would like to have an HTTP endpoint where instead of having a continuous session or connection, you can just throw your queries to a database, and the database will process it, and it's almost like a messaging type of an interface that you want to create with your database.
Oh, interesting.
Right. So I think serverless application stack would be a big thing in the next generation of applications, and we are perfectly positioned for that. I already talked about parallel query. I mean, what parallel query allows you to do is to essentially do light analytics type of queries on the operational databases, right? People typically have OLTP and OLAP. You have analytics or data warehouse in a different database, and you have operational or transactional database on a different type of database. And when you want to run your reporting or analytics queries, you move your data from your operational database to a data warehouse and run those queries. With Aurora Parallel Queries, some of these things actually can be done right where the operational data is without having to move it. And of course, that will give you fresh reports, right? Because sometimes when you have to move to a different database, the data is still.
Yeah.
What we are also thinking about doing, I mean, if you kind of extend this thing a little bit past just the analytics, people actually store a lot of interesting data in operational databases. And they would like to run various different types of machine learning algorithms on those data. I'll give you an example. So a lot of chat applications stored their chat strings on Aurora, right? Now, what people would like to do is to whenever somebody is typing some message and that is getting stored in Aurora, you might want to do a sentiment scoring on that data, right? I mean, whether somebody is happy, angry, excited, and that would be interesting if you're running, for example, a call center.
Yeah.
Right. You can do various different types of machine learning algorithm like clustering, like k-mean and things like that, which data is already stored in Aurora, and we can extend through a SQL interface, make it very easy for people to run those machine learning type of queries on the data, operational data that we already have. I think that will be an interesting way of getting into a new space, right? Other thing which has become quite interesting recently, what we call global databases, right? I mean, you have many applications where your users or customers are spread around the world. For example, if you have a travel website or a publishing website or a gaming application, your users are not local, they're everywhere, right? So you want to have a database which is distributed around the world, but you are going to expect local latency or local SLA when you access the data, right? So that is one thing we are working on. We call it Aurora Global Database, which is not out yet, but will probably come sometime soon in a data center near you.
Well, that's great. There's so much stuff.
Good stuff.
So, on that note, how would you recommend for someone to keep up with this? Or say you're new, like we talked about people that are maybe new to the cloud, new to AWS, like walking in here, there's so much stuff. How might you recommend to someone to understand and figure out which relational database is right for them?
Well, it is an easy answer for me because I would tell them that use Aurora. But seriously, I think, there is no simple answer to that, right? I mean, there are different reasons people use different databases. Many times it's convenience, right? I mean, for example, I have seen customers who are moving from on-prem into cloud. Their first step, they want to have the same database they have been using, right? And my suggestion is that, if that helps you transition to cloud faster, I think that is probably the best thing to do, right? And once you are in the cloud, I think, my suggestion to customers is that you probably want an open source database, right? And Aurora is a very good choice in that situation where it gives you compatibility with either MySQL or Postgres, depending on whether you have expertise in that particular area, right? I mean, these are sometimes customers who are experienced in MySQL. I think Aurora MySQL is a good option for them.
Yeah.
There are customers who are experienced in Postgres. Aurora Postgres is a good option for them, right? And in some cases, it depends on specific features that you're looking for, right? I mean, if you want serverless, for example, Aurora is a very good option for you. Aurora MySQL is a very good option for you. Sometimes I think compatibility with your commercial databases might drive you to Aurora Postgres. For example, if you're coming from Oracle, Aurora Postgres is a good option for you because migration is simpler than any other database, for example.
No, it's great. And also we actually have new tutorials too, like for Aurora Serverless, so people can kind of figure it out and go there and go hands-on and follow the steps and not get lost.
It's almost like, kid in a candy store, right?
Yeah.
There's so many different things to play around with.
That's definitely true. I mean, one of the things I would recommend for folks that are looking into this would be go play, go try.
That's right.
Go start a couple of these up, follow some directions. There's also sample applications people can look at and such. Okay, well, before transitioning into Q&A, I do want to leave it open. Is there anything else, talking to everyone here, that you want to add or say to everyone? Or?
I think my only message is that my job as the general manager of relational database service in AWS is to give people the best managed relational databases that they want. I would like to hear from you if there are things that we can do better, if there are new feature functions that you want. There are many different ways of getting in touch with us. Maybe we can, provide that information.
Yeah, we definitely will.
And I would like to hear from you. And, we are a very customer-centric team, very customer-centric company, and we work with customer to make this service better and better every day.
That's fantastic. And you heard that. So what you want, put it in there, ask us, and we'll ride it up the food chain and see how we can make this better.
It's going to show up, sometime very soon in a data center near you. And that's the way we started serverless. We, went to reInvent. People are very excited about Lambda. Mm-hmm. Said, hey, can we do something on the database side also, which will make databases serverless? That's a great idea. And now we have Aurora Serverless.
That's fantastic. And that's a great story. And that's even more fuel to tell us more of what you want. And we will bake it into the products and the services. So thank you very much. That concludes our presentation. And what we're going to do now is move into live Q&A, where we'll take several questions in the time that we have remaining. Please continue submitting any questions you have. We're going to get to them, and we're going to try to address everything that we can, as many as we can. And if you have your email addresses in there, we'll try to follow up with you afterwards as well if we don't get to them. So with that being said, I'm going to go open up the laptop and take some live questions here. All right, let's look at a couple of questions. Okay, here's one that came in. I thought this one was going to come in. RDS on VMware was mentioned on stage at VMworld. When is this coming, and how does it work? And are you actually managing VMs?
So we are not managing VMs per se. We are managing databases running in VMs. It's coming soon. I expect this to come within the next few months. And what we are really trying to do is that we know how to manage databases in the cloud. And if we extend our reach, there are many databases that run on VMware vSphere, right? And we are essentially extending the same technology that we use within AWS to manage databases on VMware. And this could be databases, running, for example, in customer's data center or, some other place. And they are going to get the same feature functions with respect to management of the databases, provisioning, scaling, patching, HA, backup and recovery, etc.
Yeah.
And they can not only do the backup locally in their data center in the vSphere cluster, they can also back it up, for example, in AWS. We can run hybrid read replicas that you can have the database running in vSphere and the read replica running in the cloud. And people would be able to, for example, with a couple of clicks, migrate their database from a vSphere cluster running on-prem or some other place into AWS cloud.
Wow.
So kind of make it very simple to run, applications which are spread across vSphere cluster and on-prem databases in AWS.
It's like RDS from ground to cloud kind of management.
That's right.
That's pretty awesome. Okay, let's get some more here. So any customers they're using, we talked about this before, with a lot of different RDS engines. The question is, how many are using multiple ones at the same time? Is that common?
It is actually pretty common because, there are different teams within customers, various different customers we have. There are some teams who run, for example, MySQL. There are some teams who are running Postgres.
Yeah.
They continue to do the same way when they move to the cloud. There are people who are, for example, running SQL Server or Oracle. They are in the middle of a transition. Some of their database still running Oracle and SQL Server, some running Postgres, for example. So it's pretty common for people to use multiple databases. And one of the things RDS does is the same API and kind of the same workflow that manages all of these databases. So you don't have to learn various different management interfaces and APIs to manage your databases if they're different. It's the same interface that you can use to manage all of them.
That makes it really interesting. Yeah, it's simple, and it actually ties in like the VMware thing as well,
That's right?
Wow, pretty cool. Let's get some more here while we still have some time. Here's one. I don't think we talked about really, but it was mentioned. Can you tell me more about Multimaster and when Multimaster is coming out?
Right. Again, I think it's going to come sometime very soon. There are actually two flavors of Multimaster that we are working on. The first thing that we are going to make available pretty soon, in fact, we are already running a preview of this, is in-region Multimaster. So this is essentially Multimaster which runs across multiple AZs or multiple data centers within a region, right? I mean, you can think of this as something like an Oracle rack, but runs across multiple data centers. And then the next version of that is going to be multi-region Multimaster.
Wow.
Right? So this is where the master nodes can be distributed across multiple data centers in various different regions, more like a global database. Yeah. So that's going to be next.
That's really exciting. Let's think about the power of that. Actually.
That's right. That's right. They're very, very interesting application in that sphere. Now, one thing I want to emphasize is that in both of these cases, it's going to be fully MySQL and PostgreSQL compatible, and this is uniquely different. There are actually examples of multi-region, Multimaster databases where the interfaces are different, right? I mean, it's great to have a multi-region, Multimaster database or a global database, but if you have to rewrite your application in order to use that, the value of that actually goes down significantly.
Total pain.
That's right. So that's one thing, that distinguishes Aurora from some of the other databases that I know of, that you don't have to rewrite your application. If you're running MySQL, you can run it without changing anything on Aurora. If you're running on PostgreSQL, you can move your application without having to change a bit.
That'd be super helpful. So one of the questions I read ahead here, and it kind of ties in because the question was, when we talked about compatibility with MySQL and Postgres, with Aurora, like what does it actually mean? I mean, how difficult is it, if you're swapping out local MySQL for, let's say, Aurora MySQL?
Right. So Aurora is 100% MySQL 5.6 and MySQL 5.7 compatible. Oh, wow. So if somebody is running their application on MySQL 5.6 and InnoDB, or running their application of MySQL 5.7 and InnoDB, they can move their application without having to make any changes. And that's extremely powerful. And I would actually say that's one of the reasons. Not only MySQL, now we support PostgreSQL compatible version of Aurora. That's one of the reasons Aurora is the fastest growing service in AWS, because yes, it's good to have a great database, but if people have to rewrite their application in order to move, that becomes a little bit of an issue. When it is fully compatible with something that people have been already using, it's very simple. And even when the databases require a little bit of change, for example, in case of Oracle and SQL Server, we have made it very, very simple for people to migrate using database migration service.
No, that's great. You're hitting them right here. So the next one, the question comes up along the lines of migration. Right. Are there any typical migration patterns that you see, or, to be truthful, any challenges or hiccups that are common?
Yeah. So there are actually two types of migration pattern that I see, right? I mean, especially to Aurora. Okay. Right. There are customers, the open source people using open source databases like MySQL and PostgreSQL they want a better database, which is more scalable, more highly performing, and more available. And those are the customers who have outgrown those databases. They are moving to Aurora. And then there are customers who are currently using Oracle and SQL Server, and they are kind of tired of managing the licenses and paying for their licenses.
Totally.
They are moving to Aurora, right? So those are the two patterns that we see. From MySQL to PostgreSQL, it's a very simple migration because it's 100% compatible. Now, from Oracle and SQL Server, there are some changes sometime you have to make, right? But we have made it as simple as possible with our database migration service and schema conversion tool. The schema conversion tool automatically goes and figures out what are the changes that you need to make before you can move those databases into Aurora. And typically we have very, very high conversion rate, and we are improving that as we speak. So every month we get better and better number in terms of the schema conversion rate.
Great, and things like DMS or database migration service, we have those links actually in the plan here, so people can get those.
You should play around with that.
Yeah, that's great. I don't know if we can answer this one, but are we looking at any other engines to support with RDS?
So, I'm probably not going to telegraph anything. We, of course, look at various different engines depending on customer demand and request. If you have the request for any specific databases that you'd like us to support, I would like to hear from you.
Great. Yeah, send those questions in. So another last one here. We talked a little bit of different growth and scalability of these things. Are there any size restrictions or limitations with RDS and or Aurora?
Well, there's of course some limits. In case of Aurora, for example, we have a limit of 64 terabyte in terms of the size of the single database, right? We haven't had many occasions where we have hit that limit, probably, 2 or 3 times, if I can remember, but that's a pretty large database, but that's the current limit we have, right? In terms of the size of the instances, we support up to 16XL, R4 16XL. And in terms of, for example, the size of the cluster, it's a 16-node cluster. It's a single master and up to 15 read replicas. Very soon, those are going to be read-write nodes, not just reader nodes. So it's a 16-node clusters. In RDS, some of the limitations we have, for example, today we support up to 16 terabyte of storage volume, and we hope to increase that sometime very soon. And in terms of the size of the instances, we go from all the way from T2 micros to R4 16XLs.
And if anyone has any questions on this, it's all on the website. All the different sizes you can choose from, that's limitations, right. All that kind of
And for commercial engines, by the way, we also support X1s, Oracle.
Great. So I'm looking at time. We're up and taking a bunch of questions here. If we haven't gotten to them, we're going to do our best to follow up with you. With that, I'd like to go ahead and wrap up today's Fireside Chat. Again, I'd like to extend a special thank you to Debanjan for being here and for a great time talking with you and great presentation. I think I've learned a lot. I think others have learned a lot as well. If you have any comments or previous and upcoming webinars or suggestions on the topics that we might cover, just like topics for our content that we want to put into our services, let us know. Please email us at aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming.
Thank you, Larry. Thank you for inviting me. And we'd love to hear from you.
Thank you again. And thanks for taking the time to join us today. And please enjoy the rest of your day.